Hello, my name's Mark and welcome to RCHacker. Now, the other day I was looking at HobbyKing and a new item came up, and it was the Minim OSD version 0.1. Now, I bought this one here on eBay and it's slightly different. It's called the Jumbo OSD version 0.1. It's another clone, and the only differences with this one is these three capacitors here are a different colour. They're orange on the HobbyKing one, and then these headers here are pointed straight up instead of at an angle on board. So it's pretty much the same. All the chipsets are the same. You've got the ATmega 328 there, and over here we've got, this is the smarts of the chip and probably the most expensive. It is the most expensive component on here. The Max 7456 single channel monochrome on-screen display with integrated EEPROM. So that's the one that does all the business with your on-screen display. Now, the problems with this design of the board is with this little voltage regulator here. It's a Micrel 500 milliamp peak output LDO regulator. Now, the problem with this, it doesn't quite output enough power to power this chip, and it just gets it'll do it, but it gets a little bit too hot and they eventually burn out. So particularly if you've got 12 volts coming in here, and this has got to drop that down to 5 volts, so it's got to dissipate quite a bit of heat, even though it's not this chip here isn't drawing that much current. That's the problem with it. But you can configure this in two ways apparently. You can have it powered by 5 volts on this side, which comes from your telemetry link, and on this side, or it comes from the autopilot, and on this side power from 12 volts, which comes from your camera. So depending on your camera, a lot of people run them at 12 volts, other people run them at 9. So if you're running a camera to say 9 volts, you might have no problem at all with this little thing here burning out. There's another way to configure this. If we look on the back, there's a small jumper here which basically connects the two together. So then you can power the whole thing just off the 5 volts, the ATmega and the Maxim chip as well, the OSD chip. Now, it's also got down here, there's the ISP header here. So if you want to program it, you're going to have to either, I'm going to move these header pins here, and I'm going to move them over here, because all my links that I want to do, I'm going to hard solder them in. I'm going to take these pins off actually. So I'm going to move these ones over here and then put them here. Okay, there's another jumper here which joins the two. So the one on the bottom here joins the ground planes together, and the one on the front here, I'm pretty sure, joins the power rails together. So with this connected, I'm pretty sure this is not used at all, and you don't want to connect power up to here. Anyway, I'll confirm all this because I haven't started using that, but that's my understanding of it generally. I'll just go through what's written on the back here. You've got ground, TX, RX. So typically this is only receiving data. It depends on the firmware, but I don't think it actually transmits any data. It just receives data, usually from the Mavlink protocol. That's what most of the firmware for this is designed for. And Mavlink is a protocol that gets sent up to your plane and then back down through your transmitter and then onto your OSD stuff and your antenna tracker, and that's got all your flight data, and then you can display whatever parts you want on your OSD. So rather than having a whole lot of analog inputs and then another digital input for, say, just GPS data, which some of these OSDs do, it's just got one serial link in, and then that decodes the serial data and displays it on the screen. You've got ground and BLK. Sorry, I don't know what that one is. And then over here you've got ground, obviously, plus 12 volts. Now I'm not going to use that because I think that's all been, you know, as I explained before. And you got video in, that's your video signal that comes from your camera, and video out, and that's the video signal after it's been had all its OSD data on it, and then that goes to your transmitter and it gets sent down to your goggles or receiver or whatever. Also on the back here, this here is just part of the heatsink for the Maxim chip. So that's just on the bottom of that chip, it's got a big solder pad, and yeah, that's part of just soldering onto that. These just look like test points here, and these two pads here, I'd say you solder them together to get PAL format and leave them disconnected for NTSC. And as I said before, the ground plane on this one's already been soldered. This is why I bought it. I'm not sure what the HobbyKing ones are going to be like, whether they're actually going to be soldered together or separated. We also missed over here, we've got a little LED labelled A, and another one labelled ST. These LEDs are absolutely tiny, it's amazing how small they are. ST, and then there's a power one down there, and that pretty much makes it all up. And there's a reset button as well, so if your MCU gets all screwy, you can hit that reset button. But in most cases you're not going to be using that. You can case this up and it should be fine. Power on and off will do the same thing. Okay, and this crystal here, I'll take a photo and we'll have a closer look. So that's looks like a 27 megahertz crystal there, and that's for the Maxim. And then the other crystal, I don't know if we're going to be if it's even got any writing on it. So I'll take a picture.
Okay, and there's nothing on that crystal there, so we can probably assume that's a 16 megahertz or an 8 megahertz, which is typical for the ATmega 328.
Now what I'll do now, I'll move over to my computer so we can have a look at a few of the data sheets and what sort of source code and stuff like that is available for this.
Okay, before looking at all the chipsets and stuff, I was going to look at all the resources and stuff and alternatives with this OSD. Now this is the DIYDrones Store, and now these guys invented the Minim OSD, and they're up to revision 1.1. Okay, the price has been reduced down to $45, and this is the version. If you want to be able to plug it in and not worry about updating the firmware and all this 12 volt business, don't get the HobbyKing one, get this one. Okay, but alright, so we'll move on. That's the store where you get it. Now that's this article here, this is just off the DIYDrones Forum. It pretty much explains, it's just a bunch of comments and stuff, and explains the problems that people have been having with these things, with the version 0.1 OSD blowing up, and that's when they hook the 12 volts up generally, or even less. So might be worth a quick look. Now here's the main resource for setting this up. This is the Autocam OSD page, hosted on google.com. So it's open source software, so you're free to modify it and do whatever you want and change it and stuff like that. You can also use this in the multi-Wii as well. I think some people have got different firmware for using it with the multi-Wii, but I'm not going to cover that here. So here's a good little diagram of how to hook it up. So the pins on the left hook up to your Autopilot Mega telemetry port, and that feeds it some Mavlink data. You don't have to connect, as far as I'm aware, you don't have to connect this TX line. So particularly if you're sending telemetry down to your ground station as well, you don't want this TX line connected. Now this is the end where your video transmitter and cameras gets hooked up, and these are the 12 volt lines, and here they've got it hooked up on an external battery Now this is the typical way to set it up, and the reason why they use a separate power supply is so you don't get noise off the servos and ESCs coming in and then messing up your on-screen display and your video signal. So that's why they have it on a separate power supply. Moving on, just have a look at the quick installation guide. The other setup, where if you want to power the analog side of the Maxim chip off the APM telemetry port, you don't connect these plus 12 volts lines, and you have to put solder blobs on the on these pads here, which is it's the same as on the HobbyKing one. Curiously, my one, the blobs have already been done, so I don't know, maybe my regulator on this one's already been blown up. Yeah, I'll find out later. That's what you get for going the cheap option. There's loads of information on this site here. It's one of the better documented open source projects I've seen. Now, another thing you will want to do if you get the HK one is you'll want to update the firmware. I think that's pretty essential. The MCU on there is supposed to have a bootloader, and what you'll need is one of these little FTDI chips. So you're gonna need to buy one of these if you get the HobbyKing version. Of course, if you get the DIYDrones version, it's gonna have the latest firmware on it when they ship it, so you won't have to worry about updating firmware and all that sort of stuff. Alright, let's move on. We'll look at the HobbyKing page here and its description. So yeah, nothing I haven't covered here, and nothing's really lying here except this 12 volt supply input. If you hook it up that way, the thing's gonna blow up. So 5 to 12 volts, yeah, not advised. And HobbyKing's gonna go through all the same problems that DIYDrones had when they had the version 0.1. When they were selling that, they had loads of them dying all over the place. So unless you're in the know, too bad. But like with any HobbyKing product, you want to do your homework before you use them, and you want to know what you're doing. It's not for beginners, this side of it. Yeah, what else did I want to say? Oh yeah, that FTDI port hooks on this end when you want to program it and do setup and stuff like that. Alright, so let's have a look at the data sheets. This is the data sheet for the voltage regulator that's on the HobbyKing version. It's only a tiny little thing, and it has trouble dissipating all that heat when it goes from 12 volts down to 5 volts. Now the latest Autopilot version has a switching regulator which solves these problems entirely. It's much more efficient. It doesn't have to dissipate any heat, so or a lot less heat. Anyway, yeah, this is the little chip that blows up. Alright, so get rid of that. Alright, this is a data sheet for the ATmega 328, where everyone's familiar with that, and if you're probably not familiar with that, you probably don't want to look much further, because I'm going to get a little bit technical now. Now this is a data sheet for the Maxim 7458 chip. Okay, scrolling down, there's a functional diagram there. It's got a digital to analog converter, video driver, character memory, display memory, OSD generator. Now these are very clever chips. They're working quite hard, and then they're actually adding information to the analog signal that comes in, to get those little characters printed on the screen. Now there's a couple of things I highlighted in here. Yeah, supply voltages there. It's got to be 5 volts. Analog supply current, it's only 24 milliamps. So these things are over. These little voltage regulators are blowing, and they're only providing 24 milliamps, which is really surprising. And if you've got them incorrectly configured and you've got those solder blobs soldered on there, it'll try to power the 328 as well through that one voltage regulator, and then that's when those voltage regulators go big time. They'll just go in a second. So if you get it wrong, yeah, and even if you've got it right, eventually they'll get warm and bust, sort of thing. Scrolling down, yeah, lots of technical info in here. Here's a little image of what it's capable of doing. I had some things highlighted in here, just bear with me. Here we go. Here's the typical operating circuit, and this demonstrates why basically the separation of the analog side of the Maxim chip, so that stops you getting interference on the video signal. So one side of the chip is powered by 5 volts, and in that case it was that other voltage regulator, and then the other side of the chip, the digital side of the chip, is powered by the 5 volts that come from the Autopilot Mega. And I guess internally in this chip as well, there'd be a bit of noise going internally as well, perhaps, although they haven't stated here that it's separate rails. So whether the voltage regulator is powering both the analog side and the digital side of this chip, I'm not sure, but there's definitely a separation there, particularly to remove the noise that comes from the Autopilot Mega. Now if you're running a multicopter or something like that and you've got ESCs on it, you're going to have loads of noise coming off that sort of thing. So if you're running a multicopter or anything like that and doing FPV, you'd probably be better with the DIYDrones version. Yeah, and the rest. Here we go. Here's some pictures of the characters and stuff. You've got black and white and transparent, and how they're all set in memory, and you can actually customize your own characters, and that's what the Autocam OSD project has done. Like, they put their own characters in and little symbols. This is the default character set. There's not really a lot in there, but I keep forgetting the name. The Autocam OSD project has got all little custom characters in here, like the arrow that tells you where home is, and all the separate lines that make up the artificial horizon and everything. So it's really quite a clever bit of software there. Moving on, it's actually, yeah, all this data is communicated with it, I think, via SPI, or as serial communications. So here we go. Video standard select. That's another point. On the back of it, there were the two pads for the video standard select. Now this can be selected in software. So depending on how the ATmega328 has been programmed, because that's the one that senses whether that little joiner on the back here, the one that says PAL, you probably can't see it, but yeah, it's that one there. That's a legacy thing, and on the DIYDrones version, it's not even used anymore. That's actually set in software with that configuration software that we showed before. So soldering that or not soldering that, if you've got the latest firmware on this thing, it's not going to make a difference. And yeah, so there's no digital pin that's hooked up from the Maxim chip to enable or disable that one. Yeah, moving on. Just a few views of the characters with the transparency in different modes. So, as you can see, the Autocam OSD project would know this data sheet back to front, and this is what this is our engineers' bread and butter, this stuff. Data sheets and understanding everything that goes on here to design a product that works. Yeah, so I think that's it. I've really breezed over it a bit, and I'll probably know more once I start using the thing, but I've done my homework already. And yeah, so I just thought I'd share that homework with you. So yeah, that's the Minim OSD. So if you're not confident and you want to you're running your cameras off 12 volts and you're worried about noise on your video signal, or you're on a multicopter, I wouldn't go with this one from HobbyKing. I'd go with the DIYDrones one, which can better handle noise and is a bit more user friendly with the latest firmware on board. But if you're real cheap ass and tight ass like me, and you know what you're doing, by all means go with one of these, but just be aware of those issues that it has with that voltage regulator. So yeah, thanks for watching, and I'll put up on here, as I normally do, I'll put up a bunch of links to other videos on my website, and I'll probably put a summary page on my website just with a bunch of links to resources and information on this OSD chip as I come along. So I'll put that link here, and yeah, catch you later. Bye.